So here's my LED thingy. Don't really know where to start, but there's like, you can't really see that, but there's 72 0603 LEDs here. 6 TLC something or other chips over here to drive each one of those LEDs. The clock is at 12 megahertz. Keep that in mind. Over here, all these screws are counterbalanced so that it doesn't wobble when it spins super fast. Right there's a standoff, and there's a magnet. Keep that in mind. That goes into gear and standoff, and this attaches to, forget what it's called, but it basically sends wires through a rotating signal. You can see that over here. Let's go over to here. It's just power, ground, and SPI. And actually there's 6 wires over here. There's 6 wires over here, and 2 of them are tied together for ground, 2 of them are tied together for power. And then it goes into gear, 2 gears to bring up the speed, or to lower down the speed, because this goes at like really high speeds. And then goes into this thing, which I got at a hobby shop. It's for RC planes. It's to adapt the DC motor into a 5mm shaft for planes. And then on the back, we have the Teensy that's driving the whole thing, because the Arduino wasn't fast enough. It's driving it at 12 megahertz, and that's like 60% of the Arduino's, or at least the Arduino Uno's frequency. Power LED down there. Thank you, autofocus. Power LED down there because I was having some power issues. It's a capacitor that fixed one of the issues. Also, I have this tape here so that it doesn't short to the aluminum. And then, seizure alert. Oh no. Hall effect sensor, so that when it goes up, see the red LED down there, it can sync itself to the rotation. So I probably should have had it here so that it's normal coordinate system, but I have it here, so I had to shift the entire coordinate system. Kind of annoying. So that allows me to sync it so that it's, even if it's lagged behind, or lagged in front, it can resync itself. So then I was having some power issues, like I said. Oh, and there's a potentiometer to control the speed of the motor so that I can speed it up so that the Teensy can update this fast enough, because too fast it doesn't update it fast enough, which is kind of annoying. I tried going to Teensy 4, but there wasn't an SPI library out. I didn't want to go through the 1000-page datasheet to figure out how to do it. Which I have that set. So then the power issue, I have capacitor there. Motor was putting noise into the power line, which was resetting the Teensy, which is both those things there. And I have the power LED. And then the other thing is, the LEDs and the motor was taking like 2 amps of current. So that was kind of annoying, so I can't actually power this from a USB power supply. Kind of unfortunate. And then I actually had a tough time getting power. Whoa, it's doing weird stuff to the camera. Had trouble getting power out here. So this entire side over here is all 5 volts. It's just a plane of 5 volts. And then on the back, there's just ground. So that's pretty good. Oh, and yeah, I designed the PCB. And this thing is basically all made of Octobotics. And then, yeah, I can put you guys down. Here's the revision before it, which the motor runs off of this, which you're wondering, Wait a second. Why would you make the motor run off of that? Well, because the I want the speed lower, for one. And two, well, this is gonna be really loud, but speed lower, and this runs at a really high speed. So I need a lot of current if I want to forcibly drag it down, which it's not actually the right gearing ratio. Kind of unfortunate. It should be that one. Learned that. Fixed it. Not in this one. Also, there were 2 or maybe 3. No, three revisions before this. This is also this is a diffuser because it looks better when there are more LEDs or if it's diffused. So that's that part. Essentially the same concept, except it's kind of more jank. The original one was with an Arduino. It was kind of mocked up in a couple minutes. Same concept. And this actually turned from an older model to this one. So I think it's pretty good. And now I have 72 radial degrees. And unfortunately it doesn't look very good in video, so I'm not going to show it. But I'm pretty sure this one will. Maybe show it again.